In a normal distribution, in the middle of the shape is always the mean. For each gap is one standard deviation. So this is one standard deviation. This is another standard deviation. This is another standard deviation. Each standard deviation is the same distance from the mean. So if I say one standard deviation away from the mean, so this is one standard deviation. This is another one standard deviation. According to the textbook, each standard deviation is 34.13%. So one standard deviation, so in this shape, this area that I highlighted, this one area is 34.13% of the entire shape. Okay? So the same thing on the left-hand side from the mean, this is another standard deviation. So if this shape is also 34.13%. Okay? And then the second standard deviation, so if I have a yellow, so the second standard deviation, so the ones that highlighted in yellow, okay? So on this part, okay? Just the part in yellow, okay? This part, according to the textbook, the yellow part, this part is 13.59% of the entire shape, okay? So this yellow part is 13.15%. The same thing on the left-hand side. So this yellow part, is 13.59% because it's a normal distribution. Everything from the right is symmetrical from the left. Now, the very little part on the right hand side over here, the little yellow, green part here, this is only 2.15% of the distribution. And then symmetrically, this part is 2.13%. Okay? So now we know this differences in different standard deviation have different percentage of the entire distribution. Now let's talk about percentile. If you study earlier, if you go to slide number 13, percentile is the percent of observations at or below a given score. Okay? So now, if we go back to slide 21, you will know that the very first line on the screen, it says percentile. Okay? So it says percentile, meaning it's accumulative percent. So percentile. So on this left, very left, is a 0 percentile because it's on the bottom of the tail and toe. Okay? So it's 0 percentile. Okay? So at this point, this green part is 2.13%, right? So this is 0 percentile here. And then this is 2, because this is 2.15, according to the table, this is 2.3 percentile. Okay? 2.3 percentile. Actually, over here, this is like 0.1 percentile. Now, on the first standard deviation, away from the mean over here, according to the slide, it says 16. How does this 16 come from? Okay, so now percentile, again, is a cumulative of percentage. So what happened is from this 0 all the way up to this point, that comes up to the percentile, okay? Again, 0 all the way up to this 16th percentile, meaning that I add up all the percentage up to this point. So this 16 is actually 2.15 plus 13.59. It's approximately 16%. Okay? So although this adds up to 1574, but in math you can just say 16, almost 16th percentile. Okay, so normally you write 16th percentile as like this, 16th percentile. Okay, now in the middle, this is the mean. It's always 50 percentile. Okay, because it's halfway. Okay, from the very 0 on the left, cumulative all the way to the middle, it's always 50th percentile. Okay, so this 50th is actually how this comes from, 16, because this is 16th percentile, and then this part, shaped part, is 13.13%. so this is 13.13%. so when you add that up, it's about 50th percentile. Okay, so now one standard deviation to the right, again 50 plus 13.13%. So that's why on the textbook it says this is about 84.13. So this is about 84th percentile. Okay, so again, percentile is a cumulative of percentage. So now I'm going to add up all the way up to this point. Okay, so what's the percentile of this point that I'm pointing at? It would be everything, every percent adds up to this point. Okay, so one standard deviation away from the mean is 84, and then I'm going to add up this percentage. Okay, so 84 plus 13.59, it's about 97.59. So according to the textbook, this is 97.7 percentile at this point. Okay, at this very bottom, I'm going to add up to that 2.15. So according to slide 21, this is 99.9 percentile. Okay, so that gives you an idea about percentage and percentile on a normal distribution. Now you have a little more understanding on the normal distribution. Let's talk about the example on slide 14. This is a chart you can see on slide 14 where there are 65 students, and here is the record of their VO2 max. According to the data, the mean of the 65 students VO2 max is 60. So the average of the 65 student of the VO2 max is 60, which is in the middle of the bell shape. Each standard deviation is 5 of the VO2 max, which is why one standard deviation to the right, it becomes 65. 2 standard deviation to the right becomes 70. 3 standard deviation to the right becomes 75. On the left-hand side, 1 standard deviation to the left, the VO2 max is 5 below 60, equals 55. 2 standard deviation to the left is 50. 3 standard deviation to the left is 45. Now, those numbers are raw numbers. Many things can be calculated, but they cannot be compared. That's why you normally want to convert those raw numbers, okay, raw numbers into standard scores. A z-score has a mean score of 0 and standard deviation of 1. You have to memorize that. It's just the rule. So now, as you look at this chart, you can see z-score has a mean score of 0. 1 standard deviation to the right is 1. 2 standard deviation to the right is 2. 3 standard deviation to the right is 3. On the left-hand side, 1 standard deviation to the left is -1. Another standard deviation to the left, -2. Another standard deviation to the left is -3. Another commonly used standard score is t-score. A t-score has a mean score of 50 and standard deviation of 10. So on the same chart, the mean is 50. 1 standard deviation to the right, you add up 10. 2 standard deviation to the right, you add up another 10. 3 standard deviation to the right, you add up another 10. To the left-hand side, 50 to the left-hand side, so that's 10 less than the mean, so that's 40. Okay, so 40 here. 2 standard deviation to the left, that's minus another 10. It becomes 30. Another standard deviation to the left is 20. Once you have the raw score and the mean and the standard deviation, you can calculate the z-score, or the same thing over here. You have the raw score, the mean, the standard deviation. You can calculate the t-score. And you can also use this equation to calculate the t and the z interchangeably.